Hello guys, welcome to our first lesson for advanced database systems. Now for our lesson 1, lesson input 1, we are just going to have a review of the things that we have learned from IM 102. So when we say database language, we are pertaining to something that allows us to create database and table structures to perform basic data management, such as adding, deleting, or modifying data, and which also allows us to perform complex queries designed to transform raw data into useful information. A database language also must perform basic functions with minimal user effort, and its command structure and syntax must be easy to learn. And lastly, a database language must be portable, and it must conform to some basic standards so that an individual does not have to relearn the basics when moving from one database or relational database management system to another. We also learned that SQL functions is categorized into two broad categories. Actually, if I'm not mistaken, this is already updated into four broad categories. But for the lecture that we will be having for IM 102, we will study the two main categories, which is the DDL or data definition languages and the DML or data manipulation languages. Always remember that the data definition language or DDL pertains to those commands that allows us to create database objects as well as manipulate or remove those database objects. It includes the keyword create, alter, and drop. And then we also have certain commands for creating primary key, foreign key, as well as setting a column if we allow it to be null or not null, as well as all the other commands that you can see here in our first figure. Now for the data manipulation language, these are SQL commands that allows us to insert, update, delete, and retrieve data within the database table. Now it includes following commands. As you see here, it also includes operators and functions. So SQL is a non-procedural language. When we say non-procedural, we merely command what is to be done. We do not have to worry about how it is to be done. And then remember, when we say schema, we are talking about a group of database objects or a collection of database objects, which are usually tables and indexes. Okay. Later on, you will learn all the other database objects that we can add to our relational database. We also studied about the database model. Okay. And then we have a sample here between table vendor and table product. Okay. So table product is interconnected to table vendor by way of the column V code. So V code is a primary key of table vendor, which is a foreign key of table product. Now, when we are dealing with data, of course, data can be of different kinds. Now, in order for us to accommodate the different kinds of data, we make use of what we call data types. Data types in databases are almost the same as the data types found in programming languages. So when you are storing information or when you are storing data, it should be stored in means or in a proper container. So our container are those data types. Now we have basic examples here. There are lots of data types that you will encounter, but these are the most common data types. We have char and varchar. They are almost the same. They can accept different characters. Now, the only difference between the two is that char is a fixed character length, meaning when you say fixed character length, when you set the size of a char column or a char data type, the number or the size that you have set in that particular column remains the same. Okay, irregardless if you are going to use that particular size or not. Let's say, for example, if you are storing the letters, a certain letter, for example, in our column, you want to insert ABC, and then you inserted BC, and then you inserted A. We have a size of char 4, which means to say we can store up to 4 character length data. All of your records, all of your rows under that particular column will be or will have a size of 4, irregardless if you only stored 3 characters such as ABC, 2 characters such as BC, or 1 character such as A. As long as it is a maximum of 4 characters. When you use char, the size is the same, irregardless if you make use of all of the space available for that column. Okay. Now, varchar or variable character, on the other hand, is a variable length data, okay, which can accept 1 to 2,000 characters. Char can only accept 1 to 255 characters. Varchar can accept up to 2,000 characters. Now, what is the main difference between the two aside from the maximum characters that they can accept? Varchar, when you set a particular size, let's say, for example, I set the size of my column into varchar 500, and then I entered the letter A. Although I have set the size as 500, the allocation or the memory used by that particular column will only be 1. Okay. Now, given the fact that I have said that char is fixed and varchar is not, and then char consumes a fixed storage space in memory while varchar does not, does it mean that does it mean to say that it's better to use varchar than char because we can save a lot of space if we use varchar? Okay. In a sense, that is correct. We can save space by using varchar if we do not know the particular size of the characters that we are going to save inside that column. However, take note that because char is a fixed character length, meaning it does not change in the particular space that it occupies, char is actually faster than varchar. We can compare it to a highway. So let's say, for example, char has 4, meaning to say we have 4 lanes, and then varchar has, let's say, 10 lanes or varchar 10. Because we are inserting different size of data in varchar, there are times when we're only occupying 1 lane. And then suddenly it becomes 10 lanes, and then suddenly it becomes 2, 3, 4, etc., etc. So what happens if the highway is like that? It will cause a build up. It will cause a slowdown, especially on the particular row that is limited or is using limited size. Unlike char, because we have already set the length as fixed, when we are doing a query, most especially if we are doing thousands or millions of data, columns inside char will be significantly faster than those in varchar. So always remember that. That's why we have different uses for char and varchar. You can you will also encounter data types such as nvarchar and nchar or nvarchar. Those types of data types are used when you are dealing with special characters, such as, let's say for example, you are storing Korean characters or Japanese Chinese characters in your database. You must use nchar or nvarchar because they support those particular characters. And then the size of nchar and nvarchar are double because in databases, the alphanumeric characters are equivalent to 1 byte, whereas special characters such as Korean, Chinese, and Japanese characters holds one character can is equivalent to 2 bytes. So always remember that when dealing with different data types, although they might have the same uses, we must take note of the speed and the storage that they are using. Now we also have the decimal data type, which is used for numeric data. Aside from the decimal data type, decimal data type accepts two parameters. The first one is the numbers that it will be allowed to accept, and then the second one is the decimal places. So always remember that the first number or the total number of digits includes the decimal places. So in this example, we can have up to 7, okay, whole numbers and 2 decimal places, including 0. Okay. You could also make use of money data type or currency data type depending on the database management system you are using. We also have double or float in some database systems. The next we have the integer or int, okay, small int, okay, which are smaller integer values. We also have long and tiny int in some database systems. For me personally, the I commonly use int, especially for when I'm making a primary key, which are integer. I make use of int only. Most of the time, this will suffice. However, if you're using or making a table which constantly writes numerous data per day, it is better to use long. But for most common uses, int will already suffice. We also have the date data type, which is used to contain date. We also have the time data type used to contain time. And then we also have what we call the date time data type, which can be used to hold both date and time. Okay. When we say table, a table is a collection of related data held in a table format consisting of columns and rows. If you are familiar with Excel, okay, an Excel sheet is a proper or a good example of a table. So a single sheet is a good example of a table as long as there are data that is inside that particular sheet. In relational databases and flat file databases, a table is a set of data elements using a model of vertical columns identifiable by name and horizontal rows. The cell being the unit where A, row, and C. Okay. We will be using both MS SQL Server and MySQL or MariaDB for our sample codes. Now, how do we create tables? Creating table in almost all database vendors are the same. However, there are just slight differences. Let us take a look at these examples that we have. We have the same table, table sample for SQL Server and MySQL. They have this almost the same. Uh, they have the same columns. Okay. Then SID is our primary key. However, take note of the differences. For SID under SQL Server, it is not null, meaning the value should not be blank or null. The data type is integer, so they're the same. However, in SQL Server, we made use of the keyword identity 11. For MySQL, we made use of auto increment. The purpose of these two are the same. However, auto increment is not supported in SQL Server and identity is not supported in MySQL. Identity is a function which accepts two parameters. The first parameter is the seed or the starting number for our record, and the second parameter is our increment, meaning if we say identity 11, the first record will start at 1 and then the next record will be 1 plus 1, which is 2, and then followed by 3, 4, 5, 6. Let's say, for example, we have an identity here that has a value of 5, comma 2, which is 5 will be our seed or starting row. The next record will be at 7. Why? Because we start at 5 and then we have an increment of 2. So 5 plus 2 is 7. And then it will be followed by 9, 11, 13, etc., etc. Now, auto increment, on the other hand, just adds 1 to each and every record that we have created. Okay, so though that is one difference. Then the next difference, SQL Server supports the money data type. However, MySQL does not support that. However, we could make use of other data types such as decimal in order for us to simulate the same container for our amount or for our money. Okay, so I will open an SQLite online.com window here, and then kindly make sure to select MS SQL. Okay. In here, I have already pasted our code. I will execute it. So our table sample is already created. If you try to create it again, you will have an error, meaning that error states that there's already a table called table sample in our database. So we cannot repeat that particular command. Let us try to run our MySQL command. Okay. So if we try to run it again, okay, it will say that the table already exists. So we now have two tables for MS SQL and Maria or MySQL. So notice they are the same, only the difference in the syntax for S amount and our identity. So that's how you would create a table for MySQL and MS SQL. However, what if you want to create your table inside the actual program for MS SQL, which is SQL Server Management Studio or MySQL Workbench? How will you execute that particular code? So I will show you how it is done. So first, we will open our Microsoft SQL Management Studio. So make sure you log in. So after connecting, you must create a new database. Now, in creating a new database, what we could do is we could do it by code. Okay. To do it by code using create database command. For example, our database is test. Now, we place a semicolon after we have finished a line in order for us to indicate that we have finished that particular command. After that, use data. So use test. Use. Let us try to run our code. So when we try to refresh our databases folder, we will see that we have here our database, which is test. After doing that, let us use keyword use database test. Okay. So sorry, the code is used and then followed by the database name. So used followed by the database name. And then we will paste our code. So this one is for MS SQL. Okay, so command completed successfully. Once we refresh our database table folder here, you can see that we now have created our table. Now, what if you want to execute the command for MySQL? So how do you do it? First one is we create again our database. So in this example, create database test. Okay. And then click on the lightning button, which is execute, or if I'm not mistaken, I think that is F5. Sorry, Control Shift Enter. Okay. After that, use the keyword use test, semicolon again, in order for us to indicate that our command has finished. Then we paste our command. So in here, because I will not follow up with another command, if you want to not add any semicolon, that's okay. If you want to, you could add semicolon. There's no problem with that one, but it is actually preferable to add semicolon. Then click execute. So refresh our schema window here. Then you will see that our database is created and our table is already here. Okay, now so let us talk about constraint. Okay, next are constraint. So constraint are from the word itself, limitations or identifications of our column. Now, we have here different types of constraint which are both supported in SQL Server and MySQL. Take note, guys, that when we are executing code in MS SQL, we pertain to that particular code as TSQL or Transact SQL. Whereas for MySQL, it's just a simple SQL. Okay. So TSQL is the term used to describe the SQL code that is used for SQL Server, while for MySQL it simply is just called SQL. So it's just like a dialect. So we say that the SQL is Tagalog, whereas SQL is Filipino. So basically, they are the same, just some minor changes on the syntax. So with that in mind, let's begin with constraint. So under constraint, we can have primary key constraint, which is a column or combination of columns uniquely identifying each row. Foreign key, which is a column or a combination of columns establishing and enforcing a link between two tables. Unique ensures that no duplicate values are entered in that particular column. Check enforces integrity by limiting the values accepted by the column. Default defines the default values that can be stored that is stored in the column when no value is assigned. And then null or nullability designates that the column will accept null values. So from our example earlier, we will modify table sample to allow creation of primary key using constraint. So in our example, we will just be removing the primary key in our column and then defining it at the end of our last column in our table. So the syntax would be constraint followed by the constraint name, followed by what type of constraint it is, and open close parenthesis, the column or columns that we will be using for our constraint. So in this case, SID will serve as our primary key, both for SQL Server and MySQL. So let us try to do this example. Okay, so we will just copy our code. Take note, the only changes is that we move our primary key from the actual column to the very last part of our table creation code. We provided a name and then we provided the column that will serve as our primary key. So when that is executed, it will have almost the same or it will have the same result as our code earlier. Now for MySQL, let us try to do that also. Okay. So basically they have the same syntax aside from auto increment and changing money to decimal. Okay. There you go. Now, what if we want to provide a relationship between two tables and then automatically reflect the changes that occurs in the main table? So what can we make use of? So in order for us to do this one, we make use of what we call the foreign key constraint as well as the delete cascade or update cascade property. Now, if we set our tables with the delete cascade or update cascade property, what happens is that when a when a change is detected in the primary table, such as deleting a certain row, that certain row will also be deleted if it exists in the second table. Now, if an update has been done on the primary table, it will also be updated on the second table. So the code is the same. So constraint followed by the constraint name followed by the type of constraint followed by the column that we want to use. However, because we are using two tables, we make use of reference followed by the main table followed by the column, and then what particular cascade you want to use. So on delete cascade, you could also use on update cascade. Now for this example, we have to have number one, a primary key column on the main table, which also exists as a column in the secondary table. They should have the same data type, and of course, as much as possible, they should have the same name. Okay, so let us try to do this one for SQL Server. So let us remove our original tables and then paste the code. As you can see, we have now two tables. You can also do this using Management Studio if you want to, or if you have Management Studio installed on your computer. Click Run. Okay, so these are the two tables. Next, the only thing here is that you cannot insert, okay, you cannot insert data on the second table first. You have to insert on the primary table followed by the secondary table in order for the delete or update cascade to work, of course, because we are making use of a primary key here. So let us try to insert data. Then I will just copy it. Toho, then we have root, then next. Next is I will insert on the second table. So for example, chocolate. I have maybe amount is 202, price 1, and then primary key is 1. Okay. Okay. So let us try to look at the values for our first table. So we have choco fruit and meds, VID 1, 2, and 3. We also have the value for the second table. Sorry. I will. We need to update. I will update the value of check VID is equals to 2, where SID is equals to 3. Okay, then set to 3, 4. Okay, okay. So notice I have two items for VID, one which is chocolate, one for fruits, and then one for meds. Now what will happen if I delete the VID of 1 from table sample A? Delete from where, and then we select table sample B. Execute. Notice that although I only deleted data from table sample A, which is VID 1, all the related records on the second table from table sample B having a VID of 1 were also deleted. The same goes if you are to do this for MySQL. So I will just paste the code. You could try to do samples of your own if you want, but the steps for inserting and deleting are the same. Okay, notice. Okay, our tables. Okay, next are SQL indices or indexes. Indexes are used to improve the efficiency of searches and avoid duplicate column values. In the previous section, you saw how to declare unique indexes on selected attributes when the table is created. Now, these unique indexes are actually our primary key and our foreign key. Now, there are other types of indexes. Now, let's say, for example, you want to create an index on a non-foreign key or non-primary key column. You could make use of the create index syntax. So the syntax for our index or SQL indexes are create, and then it is optional if you want it unique. Take note that if you are creating a unique index, the value on that particular column should be unique. If it gets repeated and when you are adding a record, then an error will occur. Next, keyword index followed by the name of the index followed by on and then the table name followed by either column or columns. Now let's say for example, we have a table product. We want to create an index called pdate index for column P in date. We will use the syntax create index P underscore in date X on table product column P in date. Okay. Also, you cannot create or overwrite an existing index if it already occurs. Okay. For SQL Server and MySQL, they have the same syntax. However, if you are creating an index on a string column, for MySQL, you need to limit the size. Otherwise, it will have an error. For SQL Server, there will be no problem. You could use the entire column. Whereas for MySQL, you need to specify the limited size for the string column, whether that be char, varchar, and varchar, or nchar. Okay, you need to limit the size. if you try to enter a duplicate value inside our column, SQL produces the error duplicate value in index. Okay, so let us try to create an index for our tables that we have created earlier. Let's say, for example, I want to create an index for table sample B for S name. So what should we do? So if we want to say create an index, create index, create index, index name on table sample B column S name. So that is your index. So notice it will also uh, show in your particular table. Now, if you want to remove your index, use the code drop index followed by the index name. Okay, sorry, drop index, index name I'm sorry, on followed by the table name. Okay, so that it index is removed. Now, if you want to create, so this is a remark. If you want to bypass your code, just type two dashes and then followed by space so that it will not be read by our compiler. So in here, I will create a unique index. Okay, so that is our unique index. So remember, if you are making use of a unique index and then you try to repeat that the particular value, it will have an error. So let's try to do that. I will again insert mango as our S name. Okay. Notice cannot insert duplicate key row under table sample with the unique index IDX X name. The value is mango. Okay. So that is how you would do an, an index and a unique index as well as to drop them in MySQL. Oh, sorry, MS SQL. Now, what if we want to create an index for MySQL? So, as we have said, it's only possible to do an index for a string with a limited size. Okay. For example, create index. So let's make this a unique index. Okay. So there you have it. Next, we try to, okay, let us check. There's no value yet. So let us try to insert. Try to use mango, then mango again. Okay. SID, remove SID. Always remember for MySQL, you need to remove the column with the auto increment if you are executing the code. The same goes for MS SQL. So let's try to insert. Okay, cannot. Okay, okay. There's no value for VID, so we need to insert value first on our first table. Otherwise, it will not allow insertion to happen. Again, VID. Okay, remove one. Okay, next mango. Okay, then try to insert it again. It will have an error, duplicate entry mango. Okay. Lastly, okay, I have not remember if this will work. Let us try to create an index using sname, which is a string, and then let us try to limit the size. Let's see if it will work in MS SQL. Okay, so I remove the index first, and then I'll try to execute. This time, instead of using the whole column, I will just make use of 50 characters. Okay, so it will not work. It will only work in MySQL. So there you go, guys. Do that, or those are our lecture for this week about tables, constraint, and indexes. So hope to see you again next week. Thank you.